Okay, so again, for this question here, you want to find side y, then find side x. Okay, keep it as simple as you can. Do not go to a decimal. Okay, so to do the first part here, you want to find y. Is it the hypotenuse? No. 18 is the hypotenuse because it's across from 90 degrees. So I'm going to be subtracting my squares. So I get y squared equals 18 squared minus 10 squared. Y squared equals 324 minus 100. Y squared equals 224. Stop. Don't do anything more because you're going to use y squared again. Don't square root it. Just leave it. Okay? If you did want to do some work, if you're like, oh, I got to, leave it as y equals root 224. Don't go further because it's not a final answer. And absolutely don't go to a decimal. That would give you a wrong answer. Okay, so now you're working the other triangle now, and you're trying to find x. Go for it. Finish that off if you haven't yet. Find x. The next part here is that you find the hypotenuse, so you're adding your squares. Right? You already know y squared, it's 224. Now, if you didn't use y squared, okay, you could have written in here bracket root 224 squared, which equals then 224. Okay, so you do have that option. But your answer is 368. Now you got to simplify 368. Okay, so make sure you're simplified. Now you're going to do your factor ladder here, try and take out some numbers. If you haven't done that yet, do it now. I'll give you a minute. Go. Okay, so then simplifying it, you can take out two groups of 2. Right? Remember, its index is a 2. And so you had 4 root 23. 4 root 23. Hands up if you got that. Okay. Any questions about what I did? All right. Okay, let's look at the diagram for the next one then. The diagram for the next one, couple things. Number one is you want to find the distance from A to B, the diagonal. In order to do that, you're going to have to draw lines on. You're also going to have to understand that this measurement root 2 is also on the other side of the diagram. And this 2 root 3 is also over here. Like you might have to have measurements in different locations. Okay? And so you're also going to have to draw this diagonal line from A to C in order to find the triangle and the make a triangle to find the hypotenuse. Okay? So what you're going to do right now here is you're going to do a little bit of work. You're going to use 3 root 5 and 2 root 3 to find the distance from B to C. Go ahead, find the distance from B to C. The first thing that you're probably going to need to do is turn this into an entire radical. So turn those two into an entire radical. Go. Turn them into an entire radical. Okay, so when you're doing your work, you want to be doing your work with square root 45 and square root 12. Okay, now you can do Pythagoras to find BC. Go ahead, do Pythagoras to find BC. Okay, to find BC then, it's the hypotenuse. Should you add or subtract your squares? Hypotenuse, definitely add them. So you're adding root 45 squared. you're adding root 12 squared. That equals 45 plus 12. Okay, that's what's really smooth about this. Equals 57. So what does BC equal then? BC equals root 57. So that's the first step, is finding that middle part, root 57. Now what you can do is you can do Pythagoras to find AB. Keeping in mind, you're going to use root 2, so you're using this other triangle, AC, as well as BC, to find the diagonal AB. Okay, so go ahead, do Pythagoras one more time. Whoops, sorry guys, I didn't show this to you, did I? So there's BC squared, root 45 squared, plus root 12 squared, 45 plus 12, 57, root 57. Sorry about that, I forgot my screen was frozen. You're working with BC and root 2, so you're going to get AB squared, which is the hypotenuse again. So again, square root root 57, square root 2 squared. Here I don't have my brackets. Okay. Ideally I should have my brackets, but it doesn't really change anything. Okay, 57 plus 2, 59. And so what does AB equal? AB equals root 59. Okay, root 59. Now, can you simplify that? You should go and always double check that. You should do a quick little factor ladder. 59, can you divide it by 2? No. 3? No. 5? No. 6? No. 7? No. 8? No. 9? No. No. Is 59 prime? I think so. Okay, so you actually can't simplify it anymore, but always double check, because it's common for you to get an answer like through 3 root 18 or 3 root 19, right? So you do simplify it if you can. This one can't. All right. Good little review of roots and radicals and doing Pythagoras. Any questions about that? All right. Okay, let's finish off then our factors and products. Finishing off our factors and products, we just had these ones here. So area models determine the factors. So just to review here, this here in the inside is your product. All right, so this here is your product. And on the outside is your factors, the two things being multiplied together. So just doing a quick little example, x plus 2 times x minus 1. Okay, so this one here is x plus 2 times x minus 1. This will be my factors. And now you have to find the product. So to complete it, I would draw and trace the outside, then trace the inside lines, and then look at my shading. So this here is a -1, so I have to shade this one as a -1, this is a -1, and this is a -1. Okay. So then find your product. What would be your product? Well, it would be an x squared. Here you have 2 positive x's. Here's a negative x. So overall, it would be a plus x. And then your 2 here would be -2 1-tiles. Okay. Okay, so what I want you to do for number 1 then is you got to figure out what should go here and what should go there. Go for it. Figure that out. In question 2 then, you're figuring out your product. Okay, so your product is also called your area. And your factors would be like your length and width. That's why they're often called area models. So your factors are x minus 1 on the left and 2x plus 3 on the top. Again, these can switch order. It doesn't matter which one you put first, which one you put second, as long as what's inside the brackets is the same. Any questions with that? Okay, complete the next one then. Now you're doing the product. Go for it. Complete the next one. Draw the lines first, then look at the shading. Draw the lines, then figure out the shading. Negatives are shaded, positives are not shaded. Good. Okay, so with the shading, I get negative 2x squared plus 3x plus 2. Remember, your x terms are always in two different locations, and they cancel out or combine together. Sometimes zero pairs are formed, sometimes not. Okay, but there's always two different locations, and you have to combine them to get the middle plus 3x. Okay. Hands up if you got that. Any questions, comments, concerns? Brady, question? Nope, you're good? Okay. Next one then, going down. Are we done? Miscellaneous. Okay, really common question here. I have work. So the trick here is, okay, different work is not incorrect work. Okay, so different work's not incorrect work. What you're looking for here is, number one, always check your signs. Then check for a missed multiplication or a missed, sorry, not a missed multiplication, an incorrect multiplication. And then I always find you have incorrect collecting like terms. So you combine stuff that can't be combined. Right? Terms that aren't like being put together. Whoops. Collecting like terms. Those are the typical errors that we're looking for. So you just want to make sure it's all done correctly. So have a look at it. Okay. Step one, any issues? Not really. What we're more used to seeing is just using your rainbows or your flying arrows if you want to make them arrows. But really, we're taking 3x and we're just going to multiply it by all of them. So that's totally fine what they did there. And then take the minus 1 and multiply it by all of them, which is exactly, I've written this lots. In our notes, I've always shown you this is another valid way of writing the question. Okay, so that's all good. Okay, step 2, check out your multiplication, see if you see an error. Okay, watching your signs. This one is good, this one is good, this one is good, this one is good, this one is good. And what should that one be? A plus 3, okay, a sign error. All right, So then answering the question, which step is the first one? It would be step 2. Okay, and then you can write down the -3 should be a +3. Okay, you don't have to, but it's good to recognize. You want to know which the error is. Okay, questions, comments, or concerns? K-type questions. All right, K-type questions. So this is almost identical question, but number 1 is how many integer values there are, and the next one is determine the possible values. Okay, so they're asking the same thing. You got to do the exact same work, but you'll answer them differently. So let's get to work. The first thing you're trying to factor, right? What are the different factors for 3x squared plus some number x minus k? So this is a harder trinomial where you got to find the superproduct. So what is the superproduct? To find the superproduct, you multiply your outside numbers. 3 times -4, so your superproduct is -12. What is your sum? Well, that's the thing is you're finding. You're trying to find all the possible sum combinations, right? Basically you're trying to find all possible sum combinations. And we use our superproduct to do that. So what are some numbers that multiply to 12? One and, make your list, go, make your list. Start at 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9. Okay, go ahead, make your list, let's go, don't wait for me. Make your list. 1 and 12. 2 and 6, 3 and 4. Then you just be repeating, okay? Now the problem is, right, is that it's got to be a -12. So in order for your product to be -12, you must have what? It must be a positive times a negative. Has to, okay? So the first combination, right, this could be a what if that's a -1, what would be your sum? If the 1 was negative, what would be your sum? You're right, positive 11. But what if we switched around so that now this was a positive and that was the negative? What would be your sum? -11. Okay, so it would be plus or minus 11. Do the next one. So make one of the numbers negative. We'll make the 2 negative. What's my sum if the 2 is negative? It's a 4. Okay, it's plus 4. Now I'll go and make the other number negative. So plus 2, -6. What's my other possible sum? -4. See how you're doing all the combinations? First the negative sign's on one number, then the negative sign's on the other number. Okay. Last combination, make one of them negative. We'll start with the 3. That gives me a 1. Then I'm going to turn it around. Okay. So a +1. Put my negative sign on the other number, and I'll get a -1. Okay. So now you have to write your answer. Write your answer in proper numerical order. Go. How do we write this? K equals what? What's the smallest digit? 1. So you start by going plus or minus 1, comma. What's the next answer? Plus or minus 4, comma. What's the next answer? plus or minus 11. Write it in numerical order. Organize your work. Okay? So is this what we just wrote it down? Is that the answer for 2A or 2B? This would be 2B, right? This would be 2B. For 2A, what would be our answer? How many answers did we just write down? Each one represents two numbers. How many answers? 6, right? So 6 possible K values. Okay. So there's 2A, there's 2B. All right. Any questions? Guess it's taking way too much long. Next one. What value of K would make that a perfect square? So remember, with perfect squares, you can square root them, right? So perfect square, say 2x plus 3 squared. That would be 4x squared plus 9. And then you would combine them together. So you'd multiply them to give us 6x. But there's 2 of them. So the middle term is 12x. Okay. So perfect squares, there's 2 of them. So what we can do is working backwards. What would we do to work backwards with this one? 36y squared, what would be at the back? Right, square root it. Okay, so now we got to figure out the front. So to work with the 60, what would we do? First of all, you'd split it up into what? 30xy, 30xy. Okay, so what would be the letter for the front? An X. And what's the number? So what times 6 equals 30? That's what you're thinking. What times 6 equals 30? Right? So 30 is 6 times what number? That'll be a 5. Okay. Now, since it's all positives, positive signs anywhere, it would be a plus. Okay. So you're working backwards. That's a tough question, right? You got to really know your multiplications, where they come from. Okay. You've seen that a couple times. Okay. Next one. What are the 2 ways to do this? Method A, split the shaded into 2 shapes, find area, and add. Okay. So if you're doing that, you can split them any way you want. You could split it right down here. This would be shape 1, this would be shape 2. You'd have to find measurements. So here, this would be 3x plus 2y. Okay. This measurement over here is the trick. What is this measurement? Well, you would have to add those together. That tells you that measurement. So add them up. What's 2x plus x? And what's 3y plus 2y? So if you're doing this method, you would have to add to find that measurement, and you'd have to know that this measurement is slid down. Okay. So then you can find your area. So you would get shape 1 is 3x plus y. times 3x plus 5y plus shape 2, which is 3x plus 2y times x plus 2y. Okay, because they're all rectangles, length times width. Okay. Don't go any further. Method B, you would find the total area. And you would subtract the cutout, which is the unshaded. For this one, you have to be careful. You have to watch for subtraction. You have to watch for your signs. Okay? So the total area, again, you would have to find this measurement here. Okay? You would have to find this measurement here, which would be 3x plus 3x, y plus 2y. So your total area then would be 6x plus 3y times 3x plus 5y minus the cutout, which is 3x plus 2y times 2x plus 3y. And this is where you gotta be careful. Then be subtracting your answer. And you'd have to multiply the signs in. Okay? And this is where the issue is. That's where we're going to make an algebra error right with that one. Okay? So you have to be careful with that. All right. Sorry, cut that short. I wanted more time for homework. I apologize we didn't. I thought we got some good practice in, though, with the roots and powers, which is always a tough one. Work on your homework now and get as much done as possible. You have Friday night, don't do anything. You got some time on Saturday, half an hour on Sunday, half an hour on Monday night. And then you got Tuesday during flex. So you got some time to get this done, but you got to get it done. Okay? And then Wednesday, we're going to do systems, which will be fast, basically going over the test, solving some questions. And then you have some time on time on Tuesday. And then your written's on Wednesday. Okay? All right, pitter patter, get at her.